Yes, it's supposed to. All right. Wow, that's not very nice of everyone. Thanks for being a man or woman for others. Let's start with number 1. Read it for us, Lexi. Number 1.
The population of a herd of deer is represented by the function of T equals 205 times 1.13 to the T, where T is in years to the nearest whole number. What will the herd population be?
Excellent. So the formula that you're using on this first side, somebody asked in a different class, will I be giving you any formulas? The answer is no. All right. So for this one, they're using the formula A of T equals capital P for the beginning number. I'm not going to give you formulas this one. Times 1 plus the rate to the T power. Say it again. I'm sorry. The test is all multiple choice, yes.
Wait, there's no free response.
There's 0 free response.
Okay, so I'm scared. For the multiple choice, will it probably at least be in the
I guess we'll see tomorrow. Excellent. So,
Wait, what's P?
P is the initial amount of whatever you're talking about. In this case, the initial number of deer is 205. So all they're asking you to do in this problem is to evaluate this function for 6 years from now. So I'm going to replace T with 6. All right, so whatever that is will be your answer. Thank you. Oh, no. You have a phone. I heard 427. Anyone want to confirm, Giuseppe? Yep, confirmed. And the units are deer. Deers.
Okay, so I have a question.
Yes,
So, it says 1 plus 5.
correct. So that means if this says 1.13, what is the rate of growth of these deer?
3.13.
Very good, 13%.
What do we use to subtract 1 minus?
If it had said the population was declining or decreasing, then it'd be 0.87.
Okay, ask the rate, let's just say 1.13.
Correct. All right, can we go on to another one? What's the next one you want to do? Okay, so in number 2, this problem is using a different formula. It's very similar, but because we're talking about interest that's being compounded, we're going to write 1 plus our rate over n raised to the n times t.
When do we use that?
Anytime it's talking about money, interest being compounded. You'll see in the problem tomorrow, maybe, the word compounded. So n is the number of times you're compounding. And this problem says it's compounding monthly. So what is n going to be? 12. All right, so let's plug in the stuff that we know. How much money is this person putting into the account right now? Very good. So that replaces P times 1 plus what is the rate of growth? Very good. So 0.0812 over 12 raised to the 12t. Why is it 12 again?
How many months?
Compounded monthly.
Right. So I have a question.
Yep.
So this decimal, the rate, how do you convert that from percent?
Move the decimal 2 places to the left. Right? Percent means per 100. Like century, 100%. Yeah, I haven't done the problem. I'm just showing you if you can do this, then the next step is just to plug in the number you want. Yes, century is 100. What's 20? Well, you learn something new every day, Alyssa. Yes, I just want to make sure we're all good. Like, that's not the hard part, Anna. That, in theory, should be the straightforward part. So it says, how much money is it going to be in the account in 20 years? So if it had said 10 years, then T would be 10. If it said 50 years, T is 50. So now you're plugging in 20. What's up, Chris? I gave it to you 2 days ago. Yeah. And you will have the yellow calculators tomorrow. All right, Giuseppe, are you doing it for us? This one might be a little tougher to do in your phone. So maybe Lily can hit us up with the answer. Don't you have one of these calculators, Alyssa? No, Charlotte, turn it back in. All right. Well, not when I initially told you to, but you did. 888.18. One plus? 1 plus, yes.
That's right.
1 plus. All right, confirm, Lily. Confirm. And it's on the key. Yes, confirmed by me 2 days ago. 42,000. It'll be worth almost $43,000 in 20 years. That's pretty good. What's up? Well, yeah, this is assuming that this person, is it a she? Whoever it is.
They don't take it out of the.
I mean, yeah, this is assuming there's no money coming out, no money going in, which may not be the case, right? Some retirement accounts, like the retirement account I have here with Christo Ray, is I input every paycheck, some money goes into it. And then at the end of the year, they match a percentage of what I put into my account.
Oh, yeah, there's taxes or.
Well, no, this is not taxable. This is a retirement account, so it's not taxed.
Okay. When do you start getting, like I know if I was like a regular employee, they can put money into my retirement?
Yeah, big corporations use what's called a 401k. So every paycheck, you personally contribute money out of your paycheck, and they match a certain percentage. Yes, even most of those, or many of them are big, giant corporations around the world. We're doing 3, apparently. Okay, number 3. That's free money, Pablo. Pablo, do you know what that is? Yes, when you get your first big job at a big corporation, and they ask you, hey, do you want to contribute to a 401k? You say yes. And you ask them, how much do you match? And if they say 5%, then you say, I want to contribute 5% of my paycheck. You always contribute the amount of money up to what they match. No more, no less. Like if they say, we're going to match 5% of your paycheck, then great, I want to put 5% of my paycheck into the account because they're going to match it. Now, if they say, we're going to match whatever you put, then put more in. Like if you make, give me a second, let's do some real life math. Let's say you make 2,000, it is important because this is money you're going to miss out on. Let's say you make this in a paycheck. Every 2 weeks you get this much money. All right? Yes, you with me? All right. And let's say before taxes, your company says, we will match up to 5% of what you make at this company. So what's 5% of 2,500? Well, what's 1%?
0.1.
Well, yes, that's what it is. It's a decimal. Thank you. Somebody went ahead and did it for us. $125. So basically they're saying, Pablo, that every month, or excuse me, every paycheck, every 2 weeks, they're going to put $125 in your retirement account for you to use when you retire as a thank you for working here for 50 years. Every month. Or, gosh, darn it, every 2 weeks. Okay? And they say, this is the max we're going to do. We're going to max out here. This is the max we'll do. But we will do whatever you do. Right? So most companies say, we're going to match what you do up to a certain percentage. So if they max out at 5%, then you should also put 5% in. So they're putting $125 in every paycheck, and you are putting $125 in every paycheck. It depends on your company. If your company says, we will match up to whatever you do. Right?
Let's say your company says, 5%.
Yeah, you could do it however much you want. But remember, you need money to pay for things. All right? So like I'm saying that most companies do anywhere between 0 and 5%. So whatever your company does, do that.
So they take the 125 vacation.
Exactly. So it's like 120. So basically, if you do 125 and they do 125, then $250 comes out of this pre-tax before they tax. So it's saving you money down the road in paying taxes. It's as if, Gilberto, you make less money than you really do because you're going to get that benefit when you retire.
So make more money than that person.
Well, guys, I just made up a number, right? This right here, if you did the math, right, that's $5,000 a month. And if you work for 12 months, that's $60,000 a year. A third of you are going to make this in 4 years. A third of this class will graduate college and get a job with that much money. Correct. The other 2/3 will make more or less. So, a third of 20. So it'd be about 6 or 7. What I'm saying is, like, most starting salaries are between 50 and 60,000. I mean, yeah, when I was 22, that was a lot of money. Maybe it's not. I wasn't doing number 3. I was doing a little life math, which is way more important than number 3. All right. What did we learn from that? Ask about your company's 401k matching policy. Okay? It's retirement. Basically, when they say, hey, we'd like to offer you this job at this salary, you say, great. What are your retirement benefits? Yes.
So I've heard of people like pulling out their 401k.
Don't do it. It is bad. It's taxed much higher before you retire.
So what about whenever you need the company, does that mean-
They can roll it into the next company's 401k. Like, for example, I worked in Chicago, and I had so in education, they don't have 401ks. They call them 403bs, whatever. It's the same thing, okay? So when I finished Chicago, I rolled my 403b into my next 403b.
So why do people whenever like in meetings or exhibitions or whenever talking about I can't retire yet or things like that? Why?
Because they haven't saved it for retirement. They haven't been putting money into their 401k, or they haven't been putting money into their 403b. You guys, the moment you start getting a paycheck at a big, like your first full-time, 40-hour-a-week, big-time job out of college, start saving money. And I don't mean savings account. Yes, you should have some money in your savings account. I'm talking about retirement accounts. I'm talking about IRAs. That's individual retirement accounts, Roth IRA. If you don't know what any of this means, you have the internet. Google it.
Sounds like economics.
All right? It's finance. All right? Google it. Google it. What should I do so I can retire at 65? And start reading. Oh, yeah, you're going to be working until 65, man. And honestly, since Social Security will probably be done by then, you'll never retire. That's how I view it. There's not enough money in Social Security because they're spending it all. So I'm sure that I won't have it. Yeah. My major was accounting. Okay. Let's talk about Helen. Yes, the average accountant comes out and makes $60,000 a year. Not until grad school.
Did you want to do this? Or you didn't know?
I didn't know. Not until grad school. Let's do number 3 or this is going to freak out. Am I seeing the song?
I popped in my head.
What up? Also, if you are just curious, because some of you might be curious about that stuff, just come talk to me. All right? I can share with you what I know. I don't know everything, right? Obviously. I only know what my experiences are with my family and my wife's family. Like, I know what we do to help us save for retirement. But there are other people out there. I can set you up with financial advisors if you want to talk to someone that's in the field. All right? Because a lot of these places, if you go to like a Fidelity, if you go to like TD Ameritrade, they will actually put someone to work with you, and they won't be paid unless you make money. They get a fee of what you make, like a percentage, like a small percentage. All right? Yeah. Yes, compounded. Isn't it in the problem?
Yeah.
It's in there. Ooh, daily. So what am I going to put for n? There are 365 days in a year. Man, this is a hard problem, and you know I like hard problems because Helen wants to save $5,000 for a down payment on a new car. Now look at what they're asking. They're asking for how much money does she need to invest now? I'm looking for P. I don't know P. Times 1 plus the rate of 0.075 over 365 to the 365. And how many years? She needs $5,000. Because A of 3 is $5,000.
Wait, so you don't use
I do use 5,000.
Oh, and equal.
That's what I need. I need to get 5,000. Now, what I would do on this problem is I would first, do you see all this mess to the right of P? I would get all of that to be a number. So Lily and Alyssa, since you guys got those calculators, Giuseppe, if you'd like to as well.
All right, guys.
So what is the number that's next to P?
1.2.
That?
This is 2. It's just 2 2's at the end.
Two twos, thank you. Like that? All right, and then divide both sides by that number, and you should get your value for P.
Wait. Do the 30, 65 is 3.
Yeah, they're doing like all of this, Diana, became 1.2522.
Oh.
I believe, right? Yeah.
It's a lot longer, guys. 3
That's fine.
times 2.
It's fine to cut it. Lily said she cut it. It's fine to cut it when writing it, but when you divide by the whole thing. Remember, that's talking about that rounding at the end. That's when you round. So what is the number?
3992.67.
So 3,000. Basically, to be safe, what would I tell Helen to go to the bank and put this money in? I tell her 4,000. Giuseppe's right, since this is so close. I'll be honest, guys, when you go to the bank, like when I think about, not just going to the bank, when I look at my accounts online, how much money I want to invest in things, I don't ever think of, ooh, I want to invest $3,992 and use just round numbers. Like, I'm going to invest $1,000 today. Yeah.
If you want to find out what you do before that, instead of putting it in for.
This is a really good question. Should we take 2 minutes to answer that?
Yes, yes.
Wait,
yes.
what are you doing?
She already has, no.
No, I'm
If she already has 4,000 and she needs 5,000, well, she needs like, I don't know, we're going 100 instead of waiting 3 years.
Oh, so she has to pay.
I think what Pablo is saying is that if she can afford to go to the bank and put $4,000 into something and wait 3 years for a $5,000 down payment, why not just put $4,000 down now? If you put less down, it just means that you owe the bank more money on this loan, which means the interest that's calculated will be more, so you're going to end up paying more for the car.
I mean, she can just wait for a year and make that.
I'm not disagreeing with you. I'm just telling you that it's always this balance, right? If you put less money down, you've got to pay more in interest. All right? You put more money down, you have to pay less in interest. But that means you need more money. So you probably have to wait longer to do it. You know, like most people, when they're saving up to buy their first house, they're saving up for that down payment on a house. All right? Of course they could buy it right away, but if they don't have enough money to do the down payment, they're going to pay a lot in interest. All right? And there's something called private mortgage insurance. All right? And private mortgage interest, where if you don't, the way you want to think of it, I'm just crushing this. All right? Basically, when you guys look to buy your first house, you need to be able to afford 20% of the what you're going to pay. So let's say you want to buy a $300,000 house. Okay? What's 20% of $300,000? $60,000. If you don't put down $60,000 towards your mortgage, they're going to charge you a higher interest rate because you have not hit this 20% to cut off the PMI, the private mortgage interest.
So you're saying that you have to pay $60,000 a year?
No, so let me explain. Basically what you're saying, this is what a great class, it's not helping you for tomorrow's test, but since you're skipping anyway, it don't matter. So, what I'm saying, Dino, what I'm saying is, you go to the bank, you say, I want to buy this house. And the bank says, great, how much is the house? And you say it's $300,000. The bank says, okay, what can you put down towards a loan to buy that house? Because you don't have $300,000. All right, and you say, okay, fair enough. I have $60,000. If you need to talk, you just go outside. Okay. I have $60,000. They say, perfect, because $60,000 is 20% of $300,000, which means that we don't have to charge you a higher interest called the private mortgage interest. Okay? Now, you put that down, and so what's 300 minus 60? 240. So that means your mortgage is $240,000 plus interest, right? And the interest rate right now is probably somewhere between 3.75 and 4.5. All right, so basically every month you're going to pay money to the bank that's going to lower this number because you owe the bank $240,000. They're going to finance the house based on this much money. And for 30 years, you're going to pay them back every month to get rid of this number.
Well, it doesn't necessarily have to be 30. Because some people choose like.
Of course.
8 to 15.
I'm just going with the conventional 30-year loan. Okay, Diana, you're right. There are 15-year loans, but that just means that you have to put more money down.
Why would you just finance?
That's not a course at the school.
Well, then you know what? Going on straight.
So wait,
Too little, too late.
so you get the loan, but it's only 40,
Yeah, so like your loan is $240,000.
are you gonna pay 60 every year?
No, so you never pay the 60 again. It's a one-time down payment to basically cover the 20% of your total cost. All right? So basically every month you're paying, probably if it's 240 for 30 years at about 4.5% or whatever it is, right? You're probably going to have a payment depending on how much insurance you have, all this other stuff, your property taxes, where you live. You're probably going to have somewhere between $1,750 and $2,000 a month that you're putting towards.
What about a house if you wanna like rent it and then it's like?
Well, that's renting is different, right?
No, not like renting it yourself, like. You
Oh.
buy it and then renting it, like.
Well, then it becomes an income property, and you have to pay taxes on that. But the money you make, if you rent it out, most people, when they do that, it's called a rental property. Most people will take that money that they earn and use it to pay off their mortgage.
Yeah.
HGTV has great shows about that,
Wait, what?
where you buy a house that has like an apartment or something in like the basement or something, or like what? Oh, we want to do the actual problems? Yeah, my bad, Bashir. All right, Bashir said number 4. Yeah, good question. No, I don't think there's any brackets. Did I put on the answer key a bracket? Now, it should be on all of these domain and ranges for exponentials. Should be,
It's the same though, right?
domain is always the same, negative infinity to infinity. But range might change based on where your asymptote is. Okay? All right, so let's plot this. Give me a T-chart.
-2.
All right, so I'm plugging in 3 to the x is my function. So what's 3 to the negative second power? So it's 1 over 9, right? Because 3 squared is 9, but you put it in the denominator, so it's 1/9, which is in essence about 0.1. It's very small. What about 3 to the negative first power? 1/3. There's 1 over 3 to the first power. Anything to the 0 power is actually 1. 3 to the first power is 3, and 3 squared is 9. So let's plot these points.
You can just put that in the
Yes, and if you're using the yellow calculators tomorrow, what button do you push to type this in?
table.
Table, very good. Type in table. I'm going to do my best here to draw the curve. Now, is this exponential growth or decay? How do you know? Because it's increasing the whole time, right? From left to right, it's increasing. What's another way that you can know that it's growth? Do you see this right here that says 3 to the x? It's not that it's positive. It's that 3 is greater than 1. If the base is greater than 1, it's going to be exponential growth. So if the base is between 0 and 1, then it's decay. Do you remember when, I think there's a problem on this review, or maybe there's a problem that we did in the past where it was like 1/4 to the x? Do you remember this? What's 1/4 as a decimal? 0.25, and 0.25 is between 0 and 1. So this would be exponential decay. All right, exponential decay. Everybody good? Okay. All right, now the domain. The domain is all real numbers, so negative infinity to infinity. It's always like that. The range is not always the same. In this case, our lowest y value is just above 0, going to infinity. And our horizontal asymptote is y equals 0. That's always the horizontal asymptote unless I throw in some transformations. Remember, I think it was 6.2. We moved them up, down, left, and right.
Yeah.
I think it's later on in the review there's one. Maybe it's the next question, actually. So the next question where it's transformed.
Yeah.
Should we just do that one?
Yeah, can we do that?
All right, let's do it. Is everybody good on 4?
Wait, why is
Hold on, but she was asking first, sorry. Oh, I'm sorry. Are you talking about this? I just was showing you that if it would have been this would be exponential decay. This is exponential decay. A completely different thing. Because it's 1/4 is 0.25 as a decimal. You're looking to be, if the base is between 0 and 1, then it's decay.
if it's in a fraction, then it's going to be decay.
Be careful, right? I mean, most of the time, yes. But what if the fraction was 5/3? If the fraction was 5/3, that's actually above 1, so that would still be growth. So just be careful with making those, like, it's always going to be decay if it's a fraction. It will be most of the time, but just be careful. Dina. So I know it's hard to see, but there is actually an imaginary, like, dotted line right here that it's never crossing. Right, it's getting closer to 0, but it's never going to touch it.
So horizontal asymptote is something that it does touch.
Yes, it'll get closer. So if we were to keep going in your table, like tomorrow in your calculator, if you went to -3, Dina, and -4 and -5, these numbers would keep getting closer and closer to 0, smaller and smaller. This is exponential growth. Yes, this is growth. It usually is 0 unless I move it. If I move it up or down, it's going to change. Shall we do number 5? I think number 5 is where we move it, right? Okay. Here we go, number 5. Why does it do that? 20 questions. 20 multiple choice questions. It does. All right, so what I'm going to do is I'm going to plot this one right here. F of x equals 2 to the x. All right, so let's just plot that. I'll plot it in black up here for you so you can see. I'm going to use -2 again, -1, 0, 1, and 2. So what's 2 to the -2nd power? Should be 1/4. What's 2 to the -1st power? 1/2. We know anything to the 0 power is 1. What's 2 to the 1st power? And 2 squared is 4. So let's plot these. Now, the first thing I notice after I finish drawing this curve, this exponential growth curve, is I notice my asymptote on the original is y equals 0, but where is the asymptote on the one that's been moved?
-2.
Very good. So it's down here at -2. So that, to me, tells me I'm going to have a -2 at the end of this new equation, this new function. So that's something I always do, is I look for the new asymptote. Wherever the new asymptote is, that's going to be my horizontal shift. We're going down 2. Yes?
So we're looking for things in the new range.
I don't think we're looking at for this one. For this one, it wants to write, what's this new function?
Don't we just put 2x?
It's still going to be 2 to the x, but there's going to be a left and right switch, yeah. Why is it -2? Like, do you see how this is the asymptote for the new one? Because it gets closer and closer, but it's never going to touch it. So whatever the new asymptote is, Jimena, put that as the vertical shift. So Jimena, if it had been up here at 4, then it would be +4.
Oh, we can put that in parentheses?
You can, but no, you don't need to. Now the question is, if we're moving 2 down, how much are we moving left or right?
0.
Now, here's the way I do this, and it's up to you. What I do is I try to find, if this is 0, 1, where is the 0, 1 on the new one? Like, basically, where would I count? If I count 2 down, am I at the point on the blue?
No.
If I count 2 down, I'm not there. How do I get there?
2.7.
Well, I think my brain is not doing a good job explaining this. Yeah, very good. So it goes down 2 and then right 1, and now I'm there. So I'm trying to show you that this 0 value just had a moment there. This point is down 2, which we already know, and then 1 right gets it on the new function.
So minus.
So it's 1 right. So up here in the exponent, I'm going to write -1. Because 1 to the right, remember, think opposite, is -1. So this is the answer. That's a tricky one. And you know what I do with tricky ones? I put them on the test.
You don't have to write the horizontal.
Nope.
You just have to write
That was me trying to show you how my brain does it. That's the -2. The -2 here is 2 down. The -1 is 1 right. Yes, Charlotte. Yes. Is everybody good with 5? Okay, Charlotte. 11. Charlotte would like to go to 11. Let's go to 11. You got it. Here's 11. All right, so it says to take 3 logs, log z, log x, log y, which are all connected by subtraction, and write it as one big log, which means I'm going to have a big argument, all right, in parentheses. What's the first letter you see? Z, so put that in the numerator. What's the next letter? And it's connected with subtraction. When I see subtraction, I think division. So x goes in the bottom because it says minus log of x.
Oh,
All right. And then what about the log y? That's also subtraction, so that goes also in the bottom. So the answer, if I made it look a little nicer, is the log of z over xy. Yes, Pablo.
Why is b by itself with all of them? I mean, is this the one that begins?
It's the only one that's positive. Right? Positive log z. So it starts it. Like, remember the idea is log of a minus log of b is the log of a over b. So the first one is always in the numerator. Yeah, Chris.
So if it begins as a negative, the first log you see is negative, it goes to the
Yeah, I mean, if it begins with a negative, you might want to rewrite it if there's a positive somewhere else. Bashir, did you have a question? Okay. Chad. 12? Oh, look at that. It's right there. Okay. So when I look at 12, the first thing I do, actually no, is I take each log, and do you see those numbers in front of each log? I put them in the exponent. Oh my gosh, Douglas. Give me a second. I'm just writing down all the logs here.
Wait, is this relevant to this one?
It is. This is number 12. So do you see how the first one says 3 log base 7 of v? So now I'm going to write log base 7 of v cubed. V cubed, see where I moved the 3? I moved the 3 to, I'm going like reverse power property. So the W is going to get what power?
6.
The 6. And what about the U?
1/3.
1/3. Okay? Now this problem to me looks like number 11 now. Where there's 3 logs, all with the same base. They want me to write it as 1 log. So Pablo, what's going to go on the top? V, it's no longer V, it's V cubed. What about the W to the 6th power?
10.
So because it's addition, you guys are saying multiply, so it's going to go on top as well. Because it's multiplied. And the last one is subtraction, so what's going in the bottom? U to the 1/3. Now I believe my answer key looks a little different because anytime I see a fraction exponent, I make it a radical. So here's what I wrote. This is fine, right? If you stopped here, you're good. I'm fine with it. But what I write is this. That's the cube root of u. But either is fine. I don't care. Yes, Shyla. Does anyone else want to go over one? Because Shyla's got 2 in a row now. All right, I'm going to go Pablo next. Thanks, Shyla. 8. Number 8. Number 7. Number 7.
7 and 8.
I want to make sure we're good with 11 and 12. Everybody good? Okay. I hear number, what was it? 7? All right, number 7 is going from an exponential equation, and they want us to rewrite it using logs. So I'm going to write down log. What is the base?
5.
There's no, hold on. There's no 5. It's negative 2/5. There's no 10. The base is a. This is the base of an exponential equation. What comes next? Log base a of b equals the exponent. That is it.
Can we go 8 now?
Sure. So 8, when I see log base 5 of 1 over 25, in my mind I'm doing 5 to what power gives me 1 over 125. So if you're having trouble with this, 5 to what power gives you 125? No. Just 125 is 3. And because it's in the denominator, it's going to be negative 3.
Do we really have to do that without a calculator?
Yes.
But I don't have a calculator.
I can take it away from you. Anytime.
Dang, you're mean.
Wow.
What is so nasty? Wow, without a calculator. Are you going to the office, Mr. Okay, that's it, all right. No, wait, because you remind me of Jim.
No.
Oh.
Well, we're the same height.
I think so.
He's 6'5". Yeah, Charlotte. 14. What's up? Hey, you know Jim worked with his wife, right?
So negative 3 is the answer right there.
Wait, that's the right one.
Not in real life, no. In the show. I was making a parallel. A text-to-world connection. What up?
Oh,
Thank you.
You mean,
I've been through high school.
you mean John Consistency works with his wife like
In the show.
Yeah,
So,
yeah, Emily Duncan.
No, I was talking about The Office. Yes, he did work with his wife on The Quiet Place.
They wrote a Quiet Place together.
She didn't write it.
Oh, but she produced it.
So how do you solve 14?
14! First thing I see is a base of 49 and a base of 7. I can rewrite 49 as 7 squared, because 7 squared is 49. What's wrong?
Oh,
sorry.
rewriting. Oh.
Well, in order to solve exponential equations, my first goal is to try to rewrite them using the same base. If I can't, like when you do number 16, there's no way to rewrite 12 with a base of 3. So number 16 is your chance to use the log on both sides.
Would you multiply 7 and 9?
I would. So power to a power becomes 18 minus 2x up there. Now you see I have the same base. 22nd or full.
Like you get the 2x.
You got
Oh,
it.
you want to do it both sides.
Someday.
Both sides. No, not both sides.
Both terms. Do you see how the sevens are the same now? So now all I care about is 18 minus 2x being equal to x minus 3. And now it becomes, 8th, 9th, 10th grade. I'm happy to go on. I just want to make sure that everyone knows I'm not finished. They don't cancel out. What we're saying is for this to be true, Lexi, these exponents must be the same. So I don't care about the sevens anymore.
Well, once you plug it in, aren't you supposed to check it again?
Oh, absolutely. Well, that's just wasting our time, right? You can do that. What number?
16.
16? Okay.
Are you done with that?
You're just off of correct.
Okay. So 15 first? Okay. 216 is 6 cubed. What's 36? 6 squared. This is a fun one. I like this one. So I see a power to a power. So 9x. Power to a power. 3x. And over here.
6x plus 4.
Very good. Now this actually harkens back to your middle school days where you have multiplication with the same base. What should I do to these exponents, 9x and 3x? You should add them.
But would they be squared?
No, it becomes 6 to the 12x.
No.
It's been a while since you've done that. You just added them. Okay, here we are again. We've got the same base, so all I care about are the exponents. Okay, and again, I'm not done, but you keep going. Yes?
So then, okay, if you keep on going, when you subtract 6,
I would move the 6x over to get 6x equals 4, and so x equals 2/3.
Can we do number 17?
If you simplify the fraction. I think somebody wanted 16 first. 16 first? Okay. So here's where, and this is a hard question, so you know what I'm going to say.
What?
Definitely going to be on the test. Yeah, I'm sorry. 2/3. The log of 3x, 3 to the negative, oh my gosh. Log of 3 to the x minus 4 equals the log of 12. The reason I did this is to be able to move this x minus 4 where?
To the opposite side?
No, not to the opposite side, to the front. Okay? Now, on Tuesday, I told you to take this log of 3 and multiply it by each of these numbers, or each of these terms, excuse me. So x log 3 minus 4 log 3 equals log of 12. Now, does everybody see how there's only one x? Since there's only one x, leave it alone and move this negative 4 log 3 to the other side. So what's it going to be on the other side? Positive 4 log 3. They do not combine. Okay, I'm going to pause here. Everybody okay? No, what's wrong, Diana? Okay, we're in room 222, Christopher Jesuit, 1600 Montgomery Street, Houston, Texas, 77087, 281-501-1298. Been here for 8 years. Didn't we do something? Maybe you guys were here. Maybe it was before you, where we like voted on what we should name Mount Carmel Street. Were you here for that? It was like Father T.J. Martinez Way or something. What's going on with that? City of Houston said, no, we're good. All right. Probably. Sylvester. Yeah, not Washington. I do love Washington. What were we doing? Diana, what's wrong? Third step, I multiply log 3 times each, and then I move this to the other side. Got the exponent, put it in the front. That's called the power property when you have a log. Then I distributed the log onto each. I'm going to finish. I am going to finish the problem. The 3's, give me a second. I'm going to write x equals the log of 12 plus 4 log 3 divided by the log of 3. This is the answer. I divided by log 3 to get rid of that. Now, this is the answer. The other answer that's acceptable, Gilberto, do you see how there's one log in the denominator? Since there's one log in the denominator, you could divide each of the terms on top by the log of 3. So I will also accept the log of 12 over the log of 3 plus 4. And here's how my brain does that. Do you see how that's a fraction? And then the log of 3's cross out. When I divide those, it leaves me with just 4. Both of those are acceptable. It's a multiple choice, so it depends on which one I wrote. What's that one from Fortnite where they go like? Isn't that what's that dance called? What is it called? Can you do it for me? Oh, I want to see how to do it. I tried to do it the other day and I was like doing something crazy. I don't know how to do it. Isn't that's the one, right? All those 11-year-olds are like. Great question, Jimena. Jimena says, do you want us to get a decimal approximation? If the answers are in decimal, then you will. If they're not, then you're good. Find the right answer. 17. We're going to run out of time, so we better go fast. All right? If you guys would have stopped wasting time earlier, number 17. Goal number one is one log on one side. Is that happening? No, there are 3 logs. We're looking at 17. We're looking at 17. Is this one log on one side? No, there are 3 logs. When I'm solving logarithmic equations. If there's log in the question, then you're looking for goal 1 or goal 2. That was goal 1. The second, give me a second. Goal 2 is to have one log on each side. No, because there's 2 on this side. But Diana sees that they have the same base. I see addition. So when I see addition, I think multiplication. So I can write the log base 2 of 7x. Now we have achieved goal number 2. Because goal number 2 is one log on each side, or as Gilberto said, both sides. That's fine. We're not done, but kind of like before with the exponential equations, once I have the same log with the same base on each side, all I care about are the arguments. So 7x and 21 to be the same. So what makes that true? X equals 3. Cool. 13. 20 is right there. Can I do 20? Since it's right there, then I'll do 13. I'm gonna do 20 and then 13. I'm gonna call it a day. Remember to be a 0 until. Oh, good luck. You got it right here. All right. Now, 20 looks like goal number 1, but it's actually hiding. All right, you see how it's 1 log on one side and 20? But do you see this power? Where can I move that power? To the front, not the other side, to the front.
What? Everybody say what?
Okay, I'm just going to keep going. The log of 2x minus 2 equals 1. So now, Bashir, we've got goal number 1. These threes. I moved it to the front, and then I divided it to get it to the other side. So now it's goal number 1. 1 log on one side. What's the base here? 10. So 10 to the first power is 2x minus 2. 10 to the first power is 2x minus 2. So 2x equals 12. X equals 6. Excellent. Okay. Hopefully there's a lot of these then. Yeah, we're going to do 13. I'm done. What? Question? It's a common log. When there's no base and Menno is right, it's 10. We have enough time to do 13 and we're done. Here comes 13. What? Sorry, Diane, question? You just want to do 13? Got it. Was that a sheep? Ma! We're working on that with my daughter, so I'm very aware of the sheep. They do get so old so fast. Henry is 3.3 repeating. 13. No, there's no logs here. I'm going to rewrite the other side where it says 25 as 5 squared. And now we're ready. They have the same base. So these two must be the same. So 4x minus 10 equals 2. 4x equals 12. X equals 3.
Yeah.
Hold, that's a good question from Heidi. How come I didn't do what I did on 16? Because I can rewrite 25 with this base. I don't use... Logs are like my last resort, Heidi. Last resort. I can't rewrite 12 with a base of 3 because 3 squared is 9. 3 to the third power is 27. There's no 12 there. All right, good work. Pablo, question? 19? All right, real fast then. Man, not grateful at all. All right, I see 2 logs connected by subtraction. When I see subtraction, I think division. All right, there's no base here. What's the base then? So 10 to the second power equals x over 2. What's 10 squared? Nope, 100. So what number makes this true? Very good. You've done it, Pablo. All right. I hope to see you tomorrow.
They said I emailed you?
Nope.